Thank you. Many of you know that we're in the midst of an energy transition. This energy transition has taken over our automotive industry, where before we had many internal combustion vehicles running around our roads and also emitting quite a few pollutants and CO2. That is transitioning now to electric vehicles, largely. There's a lot of mandates that exist in all around the world where you're going to eliminate the sale of internal combustion engines in our vehicles. So we're right in the midst of this transition now. Some countries, such as Norway, which is out in the front, is almost complete adoption. Other countries, and where I'm from in the United States, it's a little lagging, but it is happening. And even in the US, where it is lagging, we're up to around 5% adoption of EVs. So that's part of the transition. But this transition is not only happening in the automotive industry, it's also happening in our energy industry. Whereas in the past, we relied on fossil fuels to supply us our energy. That is now transitioning to more and more renewables. It's more cost effective, but the problem with renewables that we have is that the sun doesn't always shine for solar. The wind doesn't always blow when we're talking about wind energy. And so the solution there is to also pair these renewables with very large lithium-ion batteries. So whether it's in the energy industry or the automotive industry, the center and the enabling technology there is lithium-ion batteries. So it's a massive shift in multiple industries that's happening right now. So when you have these many batteries that are out there, you can imagine there's quite a few of them. We're going to have a problem. And doesn't take too much imagination to see that there's a lot of batteries. What are we going to do with all these things? And so we do have recycling that exists today, but there's a lot of material that will be out there that needs to somehow be processed and handled. There are problems with these batteries. They are dangerous. It doesn't take too long to do a little Google search to see what happens to a lithium-ion battery when you rupture it or puncture it. They can explode. They can catch fire. So they need to be handled with care. But the good thing about these batteries is there's a lot of valuable material in them, specifically certain metals. There's metals like lithium and cobalt and nickel, and these are all expensive metals. That's what also is enabling batteries to be recycled. Because really, at the end of the day, it shouldn't be that we're mandated to recycle. It should be that there's economics that's driving the need for recycling. So I want to paint a little picture here for you and to kind of help imagine or visualize what this problem is. By 2030, there'll be around 2,500 gigawatt hours of battery production in North America and Europe. And that's only a third of the total world's volume. So that is enough batteries to fill Wembley Stadium 6 times over every year. It's a lot of material. It also makes it very difficult to have a football match. So we need a solution to this, and we need to be recycling these batteries. Now, the good news is, like I mentioned, there's these valuable metals that are in them. These metals, nickel, cobalt, and lithium being the 3 most expensive metals or most valuable metals. There are other metals in there too, like aluminum and copper and manganese. But these are metals that can be infinitely recycled. Current technologies are able to take these materials and recover the metals. And so there is recycling that's happening today, but it's not very economic. And so one of the things, and it's being written about a lot, is the problem that we have. And so it needs to be more economic. How do we do this? And so actually about a decade ago, there was some research that was done at a technical university outside of Boston, Massachusetts. There were 3 professors there that were starting to work on this particular problem. And yes, we know how to recover these metals, but how do you do it in an economic fashion? You really need a certain amount of technology, you need some certain innovation. And so they developed a way, it's a completely different way of making and recovering some economic value out of these batteries. And it wasn't just recovering the metals. It was taking in these batteries and directly synthesizing a very high value material. And it's the answer to that was the cathode material in a battery. So cathode material is, for those of you who don't know, is the most expensive material that's in a battery. It actually makes up to around half of the cost of a lithium-ion battery. And so, we on the previous speaker just showed the cost of lithium-ion batteries coming down. That's true, and we need to continue to have that come down. One of the solutions, one of the ways to enable that is to take this really high value, expensive component that's in a battery and find ways to optimize that and also continue to drive that down. Recycling is one of the answers. So, like I mentioned, current technologies don't necessarily lend themselves to being very economic and or profitable. One of the ways of recovering the metals in batteries is through smelting. And this is a process where you take batteries and you throw them into a big smelter and you essentially are burning them. There's a lot of the battery that you would lose. You're emitting a lot of CO2, so it's not very environmentally friendly, but it does recover the cobalt and the nickel out of that for reuse. But it's expensive, and it's also not very environmentally friendly. There are other techniques and technologies that rely on chemistry to organically separate some of these things, these different metals, and to separate them out back into commodities. It's better. It's more economic. But what it doesn't do is it doesn't make this very expensive cathode material. And that's really what the innovation is. So while other techniques and technologies really focus on separating out lithium and cobalt and nickel, that's good. And it is allowing a certain amount of recycling, but it's really not what is ultimately achievable out there. So this cathode material, and this is the technique and technology that's been developed by the founders of Ascend Elements, really to directly synthesize this very expensive cathode material rather than separate out the different metals. And so by doing that, you end up with a very cost-efficient and also very economically viable process, as well as an environmentally friendly process, without use of any hazardous materials or chemicals in order to directly synthesize this cathode material. So this is a new way and a new approach that is really garnering a lot of attention. So today we're starting on this journey of commercialization. So in the past decade, the technique and technology was developed. Now we're on a journey to commercialize this. Because as we all know, and we read all the time of the new large battery gigafactories that are being built to supply all of our EVs and also to power our grid and to put very large batteries on our grid. There's a lot of investment that's being done. So in the similar types of investment also needs to be done in building capacity to process these batteries. And so that's what we're doing today. So we just this year have recently opened North America's largest lithium-ion battery recycling facility to make that really high-value material. So it's essentially, it comes into us in various forms. It's scrap or end-of-life batteries. And then we go through a process, a mechanical and also chemical process to convert it into high-value cathode material. We've been sending this material out to various battery manufacturers, top-tier battery manufacturers, and they've been testing this material. And it's proving to be equivalent to the same material that is that's manufactured out of mine sources. So when you mine this material out of the ground, you generate this cathode material through our recycling process, and we call it hydro to cathode. That process produces the equivalent performing material at a far lower cost. It also produces that material much more sustainably. So when we think about CO2 and CO2 footprints, the material that we're manufacturing is at about a 90% lower CO2 footprint than cathode material made from mine sources. So this is really a game changer when we think about how to make recycling more economic and also more environmentally friendly. So even though we just started on our process of commercializing this, we went to and at our first facility in the southeast of the United States to process this for battery manufacturers. That first facility will bring in around 30,000 tons of batteries. And that's good, but that's enough to support 1, maybe 2 gigafactories, depending on the size. So gigafactories are also an important source of feedstock for a recycling process. So we don't necessarily have to wait 10 to 15 years for an EV to reach end of life. There's a lot of material that needs to be processed and recycled now. So every announcement that you see for a very large gigafactory that someone's investing billions of dollars in to build, there needs to be a recycling plant within roughly a 1 hour's drive of that plant. Every single gigafactory needs a recycling factory because those plants generate so much material that needs to be processed and it needs to be recycled. And the best way to do it is through the most economic means possible. We've also announced just recently the expansion of that for a second plant. It's also in the United States, and this is also a very large investment. It will, when it's all built out over multiple phases, it will equate to around $1 billion of investment. And so there's a lot of investment that needs to happen in the recycling industry and also the cathode materials production industry. But this will be enough to make around 250,000 EVs. That's good, but it just, as you can imagine, there are already millions of EVs on the road. There's going to be tens of millions in the not too distant future. There's needs to be many more facilities like this. So it gives you an idea of the amount of investment that's needed. And so this is just going to continue on. So this plant and our first couple of plants are started in North America because that's where the company was founded. But certainly there's a tremendous need in Europe, in Asia, really all across the world that needs these types of facilities as we grow and as we move through this energy transition. So what do we need in order to make things and increase the value of recycling and to get recycling rates up? Certainly it's a great idea. And a lot of people are even mandating it that you have to lower CO2. Recycling certainly helps that. Anytime that you're recycling materials, and once you take the time and effort to dig these materials out of the ground, you certainly don't want to throw them away. They also have a lot of economic value. You need to recycle them. And so doing it in the most efficient way possible, economically and also environmentally, is really the answer. So, and it doesn't need any type of regulation or mandates from any type of government entities to do so. So this is really something critical. I believe economics and the environmental benefits of it are really going to drive higher amounts of recycling. Thank you.